All right. Good morning. So it looks like every single group that did the warm-up got the same answer. So let's hope you're right?
Yeah.
Okay. I am going to do this problem in kind of a long, convoluted way. Good question. So why is because it's the way that you're going to have to do the ones that we're going to see today, the more complicated ones. This is called a differential equation because it's an equation with a derivative. It is separable, although it's already separated, which you don't know what that means yet. That's okay. So I'm going to show you the process that we're going to use all throughout the day today. So I'm going to rewrite my y prime as dy dx. And then I'm going to separate the variables, meaning I'm going to put the y's on one side and the x's on the other side. Now, the only y's that exist in this equation is the dy right here. So I'm going to keep that on the right, and I'm going to move the dx over to be on the x side. Now, how am I going to solve this? I'm going to integrate both sides. So when I integrate the left side with respect to y, what's the antiderivative of 1 dy? Y. So this side has an integral of y. This side, antiderivative of sine is negative cosine, so you get negative 3 cosine x minus 5x plus c. Most important thing that you can write on your paper when you are solving a differential equation is writing the plus c. Yeah, sorry.
This could be a really dumb question, but from the when you anti-differentiate dy, why don't you put plus c on that side?
That's not a dumb question. That's a perfectly valid question, right? And there are dumb questions. I'm not going to say there aren't, because there are. But that's not one of them, right? That's a good one. So why, now you could put a plus c on both sides, but it gets more messy when you have a plus c on both sides and it's not necessary. Why isn't it necessary to have a plus c on both sides?
Because if you had another constant, you could just move it over.
Right, because you can just lump all your unknown constants into one constant. So that's why we just put 1 plus c. So very good question, right? All right, good. Any other questions before we keep moving? All right, so now we've got this. The reason the most important thing you can write when you're solving a differential equation is the plus c is because a typical differential equation is worth between 5 and 6 points on the AP exam. That's a big deal when the entire 4-hour exam is 108 points. To have one part of one problem be worth 5 or 6 points, that's a lot. And here's what ends up happening. You usually get 1 point for separating the variables. You get 1 point, sometimes 2. This is where the difference between the 5 and the 6 happens. For your antiderivatives. Sometimes they give you a point for each one. Sometimes they just give you 1 point for both. But you get a point for your antiderivatives. You get a whole point for writing plus c, right? That's a big deal. But here's the next big deal. If you don't have the plus c, the College Board instructs the readers to stop grading the problem, and nothing that you write after there is even looked at. So as soon as they hit the first step with the antiderivatives, if there is not a plus c on this line, they literally stop grading the problem and move on to the next one. So the most you could get would be the points for separating and your antiderivatives, and then that's it. So make sure you always put that plus c, because the plus c is usually worth not 1, not 2, 3 points out of 108. That's a big deal for this one little letter, right? Okay. So anyway, so what do we do now with the plus c? We got to solve for c. This is called, just so you know, this is called a general solution. A general solution means that it's got a plus c in it. So it's like a family of functions. We want the specific solution that passes through the point 0, 12. So now we're going to plug in a 0 for x and a 12 for y. I'm going to do this in different colors. So we have 12 equals negative 3 cosine 0 minus 0 plus c. What's the cosine of 0? 1. So you get 12 equals negative 3 plus c. So c equals 15. And our final answer would be y equals negative 3 cosine x minus 5x plus 15. Kabam. Which is what you all got. So well done, right? Okay, good job. All right. So that was your warm-up to lead you into today's lesson, which is section 9.3, separable differential equations. Tyler, you ready?
Yeah.
All right. Right. Are we ready? Okay. Where's my... Okay, so nothing to write on the screen. We're just going to talk for a minute. So a separable differential equation, and that's all we do in this course is separable. We don't do what are called non-separable differential equations. So separable differential equation means that your original differential equation, remember that's just an equation with a derivative. So if you were to solve it for dy dx, you could write what dy dx equals as a function of x's times a function of y's. Now, one or both of those could just be a constant. That's okay. You don't have to actually have the letter x and the letter y. You just need to be able to have it be some function of x's times some function of y's. The last 2 days, we've been starting with y prime equals x plus y. That x plus y cannot be written as a function of x times a function of y. So because of that, is a non-separable differential equation. So today, all of our functions, our differential equations are going to be separable so that we can, and by that meaning we can separate the variables. We can put all the y's on one side, all the x's on the other. It has to be times because you can't have an integral of 3 plus dx. It has to be 3 times dx. So you can't move things from side to side by adding and subtracting. It's got to be by multiplying and dividing. That dx, I don't know if you remember, but the dx represents the width of your rectangle in your integral, right? So your area of your rectangles is not height plus width, it's height times width. So an integral is nonsense if you're trying to add the differential. You got to multiply. All right. So we're going to start with this one. dy dx equals x squared over y squared. So in your groups, I'm going to kind of have you do it and then I'll do it. So it's going to be like reverse teaching. So in your groups, take 10 seconds and separate the variables and check and make sure you all agree. Go. Get the x's on one side, get the y's on the other side. Don't go ahead. I hear someone going ahead. You don't have to erase, but don't go ahead. All right. Which side do the y's, we have a left side and a right side. Which side do the y's have to go on? The left. How do you know the left?
Well, we can't divide by
Exactly. The dx's and the dy's have to be on top. You can't have x over dx. It's got to be times. So the dy dx kind of drives which way you move this stuff, right? You don't get to choose. If you end up with like a y on the bottom and you don't like it, you're stuck with it. It's not like you get to say, oh, I don't like that. I'm gonna reciprocate it. You can't. Okay. So we multiply both sides by y squared, and then we multiply both sides by dx, and you end up with that. Is that what all the groups got? Yes? All right. What do we do next now? What do we do with this? We integrate both sides, right? So go ahead and integrate both sides. Should be pretty similar. So Ryan, what's the integral of the left-hand side?
1/3 y cubed.
1/3 y cubed. What's the integral of the right-hand side?
1/3 x cubed.
Oh, good job. Whoops, I almost read x cubed plus c. All right, any questions on this? Now, this is a general solution. It's fine, right? However, they asked us to, first of all, solve. When they ask you to solve, they mean solve it for y. So your homework tonight, I'm pretty sure they have like y equals with boxes where you're going to have to solve it for y. However, the College Board, for years, like 20 years, I would solve these for y first and then plug in my point to get my c. The College Board a few years ago made a suggestion to AP Calculus teachers. They gave us the suggestion, please have your students find C first and then solve for Y. The reason they have you do this, here's why. Okay, here's why. Because if you solving for Y is harder, right? Plugging in numbers is easy. If you solve for Y wrong, then when you plug in your numbers to your wrong solution, you're going to get your C wrong. And you've just lost, 3 points. Whereas if you plug in the numbers right away and solve for C, you get the points for solving for C. And then you can solve for Y and make mistakes, right? So, hi, Judy. So they suggest solving for C first. So I have learned, I'm not quite there yet in the habit of plugging in my numbers first, but I did it all day today. So we are going to plug in our point first and solve for C. So go ahead and plug your point in, the 0, 2. Plug that in, x equals 0, y equals 2, and solve for C. I'll have C, 8/3. Here's the next way that you can mess this up, right? I'm listing ways for you to mess up. Okay, so the next way you can mess this up is to not put the C in right away. To solve for Y, do all this manipulation, and then stick an 8/3 in for C at the end. Don't do that. Go ahead and put it in right away. As soon as you find the C, rewrite your function with the C in it. So I'm going to rewrite this now. Arrow here. All right, so I have 1/3 y cubed equals 1/3 x cubed plus 8/3. Now solve this for y. How do we do? Good? Do I need a plus or minus in front of that root? No, why not? Because it's a cube root. All right, good. Okay. Now, little note. The only other thing that your brain needs to think about when you are solving a differential equation is that the solution has to be a function. Has to be a function. Now, if this, instead of y cubed, say this was y squared and we took the square root, we'd have a plus or minus in front of it. Y equals plus or minus stuff is not a function. Because when you plug in a number for x, you get a positive solution and a negative solution. Two outputs is bad. So you're going to have to pick which one's correct, the plus or the minus. And how do you know which one to pick? You look at whichever one gives you the point that you're given, right? So we'll do some of those in the next few screens. But just know solution has to be a function. Has to be a function. All right. Any questions on your very first separable differential equation? All right. Keegan, you good?
Yeah.
All right. Have you already done this 8 times?
For sure.
Yeah, for sure. Okay. All right. Good. All right. So we're going to do this one. Solve the differential equation y prime equals x times 1 plus y. And then find the specific solution that satisfies f of 0 equals 5. So when we solve a separable differential equation, can we leave y prime as y prime?
No.
No. What do we have to write it as? dy dx. This is the only way to separate. So go ahead and take a minute, rewrite your differential equation as dy dx, and see if you can separate those variables. Talk to your group members. Make sure you match before you move on. And actually, once you separate, go ahead and stop, because I'm going to talk to you for 10 seconds. Should I distribute?
No.
No. As a matter of fact, whenever you're solving, trying to separate the variables, you want to undistribute. You want everything factored because you need stuff times stuff. If you distribute, you're kind of stuck, right? So it's okay that there's a 1 with the y, but there can't be an x with the y. So we divide by 1 plus y, and we multiply by dx. Now, here's my little note before you guys jump into anti-differentiating. Do you guys remember when we were first learning integrals in Chapter 5, I taught you a little trick. And I said, hey, if your argument is linear, then you can do, it would be as though that was, you could do it think about what the antiderivative would be if it was just 1 over y. And then just do the same thing with a 1 plus y. If it was 1 plus 3y, you'd have to divide by the slope. So anyway, but you could just do a u substitution if you want to. But when you have a linear argument, you don't have to u sub. You can just treat it like you would if it was just y. But just if there's a slope, you have to divide by the slope. All right, go ahead and anti-differentiate both sides. I haven't been pausing the recording at all. This will be a really long recording. All right. What's the antiderivative of 1 over 1 plus y? ln absolute value 1 plus y or y. Yep. Antiderivative of x? 1/2 x squared plus c. What should we do next?
Solve for C.
Solve for c. Plug in the point. The point is 0, 5. Have you guys already done that? No? Okay, go ahead and take a second. Solve for c. All right. All right, so now we plug in x is 0, y is 5. So we get ln of 6, absolute 6 is 6, equals 0 plus c, so c equals ln 6. You rewrite your equation right away as ln absolute 1 plus y equals 1/2 x squared plus ln 6. Any questions on finding c? All right, so the next thing we have to do is solve for y. We're going to do this together. So what are we going to have to do to both sides? We exponentiate. That's the correct mathematical term. Very good. We're going to exponentiate both sides, or we e them. E is a verb, right? Okay, so we e both sides. We don't get to drop the absolute value. We're just stuck with it. So absolute 1 plus y equals e to the 1/2 x squared plus ln 6. Now, personally, I would simplify the right-hand side, and I taught Pure Spirit how to do it, and I'm going to show you how to do it, and then you're going to practice. The next problem has like a whole bunch of that kind of thing, and then they almost every group messed it up. 2 out of the 8 groups did it right. So what I'm going to tell you here, and it's on the video, you don't have to simplify this. If you are not comfortable with logs and e's and exponents, you can just leave it like this. We still have to solve for y, but you can leave the e like this and be fine. If you want to simplify, I'm just going to show you. This is e to the 1/2 x squared times e to the ln 6, right? If you're multiplying, you add the exponents, right? What does e to the ln 6 equal? 6. So this is 6e to the 1/2 x squared, right? Okay. So now we have absolute 1 plus y equals 6e to the 1/2 x squared. You guys, that dumb blue box. Okay. You guys are used to seeing this. In your lives, you have worked with this in the past. It is very rare, I'm guessing, that you have seen this. Right? How do we solve for y when the absolute value is around the y? Oh my gosh, that was beautiful. How did you know that? Okay, and it does, right? Okay, so whenever you have an absolute value around your y, you just drop it and put a plus or minus on the other side. Now, I'm going to show you why that is, right? Okay, so just think if absolute value y equals 5, right? If the absolute value of y was 5, what could y be? Plus or minus 5, right? So whenever the absolute value of y equals stuff, then y is plus or minus the sum. So when you have to drop an absolute value from around your y, you do it by putting a plus or minus on the other side. So from here, so we're going to drop the absolute value. We have 1 plus y equals plus or minus 6e to the 1/2 x squared, and then subtract the 1, and you get y equals plus or minus 6e to the 1/2 x squared minus 1. Are we done?
No.
Why not?
We said plus 1.
Oh, because it's not a function. It's not a function. So we have to choose if we're going to stick with the plus or the minus. You don't get to just randomly pick one. You have to look at your point. So we were given the fact that the point 0.05 is on the solution. So if the point 0.05 is on the solution, you have to decide which of these signs makes that point work, right? So take a second and think about it. If you plug in a 0, which one gives you a y value of a 5? Do you all agree it's the plus? Okay, so then you rewrite and say, all right, so then y is just the positive. The College Board likes to kind of mix this up. Sometimes it's the positive, sometimes it's the negative. In this case, it's the positive. All right. How's that sitting? All right, so it's sitting. Okay. Quick review. Separate your variables. Integrate both sides. Don't forget your plus c. Plug in the point and solve for c. And then rewrite your function and then solve for y to make sure that your final answer is a function. All right. So, I'm sorry. There's one more thing before I send you to your whiteboards. So, it was like a week before break, you guys asked me if I ever missed something on an AP exam because there was something that I honestly didn't know, right? This is it. So I've taken every single AP free response that's ever been published. And in the 50 years or so of AP exams, this has only appeared one time in one part of one free response question. But I got it wrong. I didn't know how to do it. So I got the first two parts of it right, but then I didn't know the third part. So I'm going to teach it to you. I've never seen it again. It probably will never show up again. It caused a whole big hubbub when it appeared because so many people got it wrong. But that being said, I still teach it just to make sure, right? You better be safe. All right. So the domain of the solution to a differential equation. When you solve a differential equation, you have to restrict the domain. Now, the College Board, if they just said, hey, solve this, like do this, our answer would be fine. You don't have to write a restricted domain. It's only if they specifically ask you to state the domain that you have to state the domain. So here's how you find the domain of the solution to a differential equation. So step 1, it has to satisfy the domain of the original differential equation. So when you've got your dy dx, if there's any x values that need to be excluded, right, from that domain, then they have to be excluded from the final domain. It has to satisfy the domain of the solution, right, obviously. So anyway, if there's any x values that cause the solution to have a problem, those have to be excluded. So you get that, like you kind of put the two domains together. It's really the intersection of the two domains. So that's what I did when I did this problem. I took my two domains, I found their intersection, I wrote that as my answer, and I didn't know that the domain of the solution to a differential equation can only be one interval. So if you're looking at your domain and you get negative infinity to 0 and 0 to infinity, which is what I got on that problem, and then I never even gave it a second thought. I thought, all right, this is correct, moved on, found the solutions later on, and it was only negative infinity to 0. And I couldn't figure out why, And there was nothing in our textbook to tell me why. There's nothing in your new textbook to tell you why. There was nothing in any of the I have like 40 calculus books. There was nothing in any of those that told me why. I had to find a differential equations book. So I found a book on differential equations, and that's where I found the answer. So it can only be one interval. A solution to a differential equation can only be one interval. So you have to pick the interval that contains the given point, and then that's your domain. So once I knew that, it's easy, but I didn't know that. So now I know. So now I teach you. So we're going to first just practice finding an intersection of multiple domains and picking a correct interval. It sounds like big words, but it's really just kind of simple. Yes, Fran?
If both intervals went to infinity, like negative infinity and positive infinity,
You're just negative infinity to infinity.
Well, no, if like it was like a gap in the middle, there's still two intervals.
Right. You pick the one that contains the point that's given.
Oh.
Yeah. So your point has to be in that interval. And it's not really the whole point. It's just the x value. We're talking domain, right? So you look at the x value of your point, and that tells you which one to pick. All right. So I want you guys in your groups to take a minute and kind of chew on this. So suppose the domain, this is just to walk you through this process, and then we'll put it all together. But suppose the domain of your differential equation is negative infinity to 2 union 10 to 15. And the domain of the solution is negative 9 to 12. What would the domain of the solution be that contains the point 11, negative 6? So see what you can do with this in your groups. I'm going to give you about a minute or two to just kind of discuss. This is my visual method for finding an intersection of domains. For finding an intersection of domains. All right. So I do it with a big number line, and then on the number line, I just put all the numbers that are interesting. So I'm going to put 2, 10, 15, and then from this domain, I have a negative 9, and I have a 12. All right, and then I draw my domains above my number line. So my first domain is negative infinity to 2 with a bracket. So negative infinity to 2, would I put a closed circle or an open circle? I put a closed circle above the 2. All right, and then 10 to 15, I do an open circle on 10, and then a closed circle on 15. So there's my first domain, right? My second domain is negative 9 to 12. So I'm going to put a closed circle on negative 9 and an open circle on 12. The intersection of these two domains would be negative 9 to 2 inclusive with brackets, right? And then 10 to 12 exclusive with parentheses open, right? Okay, so, but which one do I pick? Now I look at my point. My point has an x value of 11. So I ask myself, well, where does 11 fall? Falls in here. My domain is the largest interval, single interval, that satisfies both domains. So it's got to have dots from both domains above it, right? Satisfies both domains and contains the point. So my final domain would be open interval 10 to 12. I kind of like those problems. That's just me. All right. Hopefully you like them too because you're about to do it. All right. Are you ready? Okay. On your whiteboards, wait. So here's what you're going to do. You're going to, suppose xy prime minus 3 equals 0. So there's your differential equation. You're going to find the solution. You're going to write it in fully simplified form. You're going to state the domain. If you have trouble simplifying, honestly, you can write it in unsimplified form. As long as it's solved for y, right? So correct is better than simplified. And the other thing I want to just mention is sometimes your differential equation, you might have to move terms around a little bit before you can start separating. All right, are you ready? I give you 7 minutes. go. We have an exciting variety of answers. I think that's just awesome. Okay, so let's walk through this. I'm going to show you unsimplified and simplified. No matter what, the first thing that you're going to have to do is move the 3y over. So you get x dy dx equals 3y. Now, my first hint of this problem is you don't have to keep that constant isn't married to the y, right? They don't have to stay together. And usually constants are easier dealt with, or coefficients are easier dealt with the x's than they are with the y's. So if you keep the coefficient with the x side, your life actually ends up being a little bit easier. If you move it to the y side, so here, let's see, what do we get? So we get 1 over y dy equals 3 over x dx. If I move it to the y side and I had 1 over 3y dy and I was integrating this is not ln of absolute 3y. It's 1/3 ln of absolute 3y. Or you could make your life even easier and pull the 1/3 in front and think of it as 1/3 absolute 1 over y, and then just have 1/3 ln absolute y. So, which is fine. Believe it or not, an antiderivative of natural log of absolute 3y and an antiderivative of natural log absolute y are equivalent. Why are they equivalent? Because ln of 3y is ln of y plus ln of 3, and the ln of 3 just gets lumped into the constant. So you actually could have it either way. But, boy, is life easier if you don't have that 3y. So, wow, that 3 is like there. What? Okay, it's gone. All right, so there we go. So this is ln absolute y equals 3 ln absolute x plus c. All right, next thing I do is I plug in my point. So when I plug in the point, coming up here, so I have ln 2 equals 3 ln absolute value of negative 3 is 3 plus c. So c equals ln 2 minus 3 ln 3. So if I rewrite my function, I have ln absolute y equals 3 ln absolute x plus ln 2 minus 3 ln 3. And if I go ahead and exponentiate both sides and leave it like this with the big 3 ln absolute x plus ln 2 minus 3 ln 3, and then drop this and put the plus or minus and then choose the correct sign, it's fine. It's absolutely fine, right? Nobody cares if it's unsimplified. The only part that makes it kind of a pain is if you have to do more stuff with it and you're having to type all this kind of stuff into your calculator. It's just a lot of typing, right? But apart from that, it's fine. Now, suppose we wanted to simplify. If we want to simplify, if you want to cancel the e and the ln's, you can't have a number in between. So when you have a coefficient of a natural log, the coefficient becomes an exponent. So what you actually have here, I'm going to write it all out, is ln absolute x cubed. And I'm going to go ahead and write the timeses. Okay. Times e to the ln 2 times e to the ln of 3 to the negative third. So, once you clean it up, I'm going to go down here now. So you get absolute y equals absolute x cubed times 2 times 1/27. So you end up with 2/27 absolute x cubed. So now when you drop your absolute value, you get your plus or minus 2/27 absolute x cubed. If you plug in, what was the point? -3, 2. So -3, absolute value is 3, cubed is 27. The 27s cancel. I want to get a 2, which means I need the positive, right? So you end up with a final solution of y equals 2/27 absolute x cubed. Or you could just have positive with this big giant e expression, right? Okay, so that was the final answer. So something went wrong there. You know what? You put the -3 in for y and the 2 for x instead of vice versa. Yeah, so that was the problem there. You guys got it. So let's see. No. Okay. All right. So yeah, we had some. Ooh, there we go. All right. Oh, okay. That was this is a plus.
Yeah.
Okay. All right.
Wait, we
Yeah.
got it. I think we got it.
Oh, I just didn't look closely. Let's see.
We just didn't simplify it all the way. Yeah.
Oh yeah, that's 2/27. Yeah, of ln absolute x cubed. Yeah, that's correct. Well done. All right. So now we got to do the domain. So when you do your domain of your original, I'm going to write out because we don't even have the original differential equation written anywhere. So dy dx equals 3y over x. What's the domain of this guy? All reals except 0, right? So I'm going to write out this in kind of steps here. So the domain, so I can spell, domain of dy dx is all reals except 0. The domain of y. Now this one depends on how you wrote your y, but you're okay either way. This has a domain of all reals, right? If you left it unsimplified, it'd be all reals except 0 because you can't have natural log of 0. So the domain of my y is all reals. So the intersection of the two domains is all reals except 0. So I have to pick the one that passes through the point -3, 2. Which one contains the point -3, 2? Negative infinity to 0. So our domain, because remember you're only looking at the x value, it's domain. So our domain would be negative infinity to 0. All right, piece of cake, right? Ready to do this on your test?
Yeah.
All right, yes. So I used my final solution, my y. Yeah. You can use your y. Your y would have all reals except 0 because you can't have natural log of 0. Right? So either way, you're going to come out with excluding the 0. Somehow it's going to fall out. Okay, this next slide is not on your test. It's in your homework, but I'm going to skip it just in case we run out of time because the slide after this is on your test and it's a big deal. So if we end up, just so you know, if you have, when you see this in your homework, if you have to solve an integral equation, you take the derivative of both sides. When you take the derivative of this, we're going to do this in 5 seconds. This is all we're going to devote to this problem. Okay, this derivative of 4 is 0. Anyone remember the derivative of the integral from 0 to x of 2t root y? It's it's the fundamental theorem of calculus part 1. So just replace the t with an x. Now, here's the part that makes this kind of confusing. Y of x, that's not y times x, that's y of x. Y of x is the same thing as y. So don't let the of x freak you out. It's just, you just erase it, right? So that's the part that makes this weird. Then you separate, you solve, and then to find a point to plug in, here's the part that's weird. is you always pick whatever number is down here, because if you plug in a 0, you get the integral from 0 to 0 of whatever your stuff is. And what's the integral from 0 to 0? 0. So you end up with, you get your point of 0, 4, and then you use that to plug in and solve for C. All right, not on your test, so not like a major important thing, but there is a problem in your homework in case you get stuck. I might work out this whole thing right when class ends today. But this is the part that we need to really focus on, because this is on your test. This is on last night's homework? It was all cooling?
Yeah.
Oh, that's interesting. Okay. Newton's law of cooling. Oh, is this a low field question? Okay. The rate of change of the temperature of an object is proportional to the difference between the object's temperature and the temperature of the surrounding medium. Or in other words, dt dt equals k times the quantity t minus m. With lots of different t's, big T and little t. There are only 2 variables in this differential equation. There can only be 2 variables. What are the 2 variables? T and T, big T and little t. K has to be a constant, and it is. It's the constant of proportionality. M has to be a constant, and it is. It's the temperature of the surrounding medium. Now, how do you know that big T and little t have to be the variables? Because your differential is dt dt. So you have to separate. Those have to be the variables, right? So little t, that's your input. Big T, that's your output. Every other letter that you see has to be a constant. Okay.
What was that again?
M is the temperature of the surrounding medium. So you'll see it in a second in context. So we have our pie problem. So you take a pie out of the oven, right? The oven's 350 degrees, so the pie is 350 degrees. So you take this 350 degree pie out of the oven and you set it on the kitchen counter. The kitchen is 70 degrees. Now, if you've been baking all day, the kitchen's probably gotten a little bit warmer because of the oven being on. However, the pie does not affect the temperature of the kitchen nearly as much as the kitchen affects the temperature of the pie. It's not like if I take a pie and walk outside that people walking around are going to go, whoa, is it hot out here, right? Okay. So the surrounding medium is considered to be a constant. And it's just the pie that gets acted on. Okay. So our M for this problem is 70 degrees. And we just consider it constant. Okay. All right. 30 minutes later, the pie is 200 degrees. We need to find a function, t of t, which also tells you your 2 variables, right? Big T, little t, that gives the temperature of the pie at any time t. So we have this differential equation, dt d little t equals k times big T minus, I'm going to plug in a 70 for m. I want you to take a minute and go ahead and separate the variables and then stop. Just separate the variables and stop. Should the K go with the big T or the little t? The little t. K should be on the side with the little t. So when you separate these variables, you get 1 over big T minus 70 d big T equals K d little t. It's okay that there's no little t's there. All right, any questions on separating? Now I want you to take a minute and integrate both sides. All right. What's the antiderivative of 1 over t minus 70? What's the antiderivative of k dt? Plus c. Why didn't I put the absolute value around the t minus 70? Because your temperature of your pie is going to cool down to that 70 degrees, but it's not going to keep going, right? It's not like it just keeps dropping until it's negative 40, right? It doesn't freeze in your kitchen. So, yeah, it hits room temperature and then it just kind of stops. So because of that, you know in the context of this problem that this will always be positive, so you can drop the absolute value. Okay. All right. So now we need to solve for C. In order to solve for C, we need at least 1 point, and we're going to actually need 2 points. But tell me a point that you know in order to compare. Something when the time is this, the temperature is this.
33.
Okay, I heard two of them all at the same time. So when the time is 0, what's the temperature? 350. I'm going to label. This is little t, this is big T. When the time is 30, what's the temperature? 200. It's not cooling very fast. Okay. All right. So anyway, okay, so I personally would use the 0 point, plug that in and solve for C. Get that? Good. So now we rewrite our function. So we have ln of t minus 70 equals kt plus ln of 280. All right. So now we need to find k. So you're going to have to plug in your other point. Go ahead and plug in the other point and see if you can solve for k. Yes, Pascal. No, but mathematically no, but for your own ease of working with the problem, you want to point to 0 and it. I'm going to simplify the log, sorry. Makes me sleep better. All right, so K would be 1/30 ln, and I'm going to cancel the zeros, so 13/28. There's my k. K should always be exact. Never ever round k. You can round on paper, but if you have a decimal in your calculator, you got to use the whole thing because you end up the k. You just trust me. Okay, don't round k. I always just keep k exact, and then life is good. All right. So, all right, rewriting again. So we have ln t minus 70 equals 1/30 ln of 13/28, that's a 28, times t plus ln of 280. All right, solve for big T. So we're going to exponentiate both sides. Which, honestly, the only thing I personally would do to clean this up would have this be e to this times e to this and put it as 280 e to the 1/30 ln of 13/28 t. Now, you could make this be an exponent, but then you still have that t. I wouldn't do it. I just leave it. So my final big T would be 280 e to the 1/30 ln of 13/28 times t plus 70. That's my final. Yours could be e to this whole big thing plus 70, right? And that's fine too. Okay, you have now found your function t of t. Here's question part B. What is the temp of the pie after 45 minutes? You may use a calculator, yes, and you're just plugging in 45 for little t.
Okay, I can do that.
Yeah, I did give you units, degrees Fahrenheit.
That's not right.
All right, technically this would be correct. It's not real pretty, right? And it doesn't really convey a lot of information if, your mom says, hey, what's the pie's temperature? And you tell her that, right? But 158.580 roughly degrees Fahrenheit. Yes.
70 as well.
Oh, whoops, thank you. Thank you. All right, so any questions on how to do this one? All right, let's do part C. When will pi be
Oh my god.
100 degrees? You can do this.
After a period of time.
You have a calculator. You can use any method you want.
It's going to happen eventually. Sometime in the future.
Since this is a calculator question, all you have to show is set up and answer. However you choose to solve it is up to you. So 100, you set your temperature equal to 100, and you write out your function, ln 1328 t plus 70, right? So you have to show setup. So you show setup, and then you can use your calculator to find the answer. Be careful if you use the graphing window. You have to adjust your window so you can see it because these are kind of bigger numbers. But when all is said and done, you should have gotten a time of around 87.334 minutes. All right? Okay. So this, just know, I'm going to kill this. All right.